Good morning, everyone. Am I audible?
Yes, ma'am. Good morning, ma'am.
Okay. Okay. So last class we have discussed about the what is water demand, then what are the types of water demand, then also you have learned about the different formulas by which you can find out the rate of fire demand. Yes. So now basically then again we have learned about what is your per capita demand. Okay, so per capita demand was what, like of the one person. Okay, what one person requires per liters of water in one day. So that is your per capita demand. Okay, for different, it may be for different uses. It might be for domestic, it might be for industrial. So any purpose, how much 1 liters of water per person is requiring in one day, it is your per capita demand. So now we have to know, like, what are actually the factors that are affecting your per capita demand. Okay, so the factors you can see here are: number one is your size of the city. Obviously the size of the city, it will be a factor, because like, if the city, if it is a big city, then what will happen, the per capita demand, it will be obviously, it will be large, or it will be more than as compared to like the smaller cities. Okay, so because in what happens in these big cities, there are like more population also, you can say, or also you can say there are more number of industries. So more number of industries, that means you need more amount of water. Yes, and also in these big cities are generally, they are all seaward, so you need to, you need to clean, or you need a healthy environment. So for all these things, if for the, in this per capita demand, it affects, it is a factor that according to the size of the city, you have to, this per capita demand is varying. Okay, so then next is your, like, climatic conditions. So climatic conditions also, it is same like for any hot or any humid this places. Obviously the consumption of this water, it will be more, because if it is a very hot or humid place, then the people, they will use the water, more, like you will be use the water more frequently for bathing, or you will use for cleaning. Okay, so you will use the water for, in lawns or gardens. So all these things, more amount of water it will be required. And also in like extreme weather, like the cities where it is extremely cold, so what will happen, the people, they will, in order to like avoid the freezing of the pipes, so they will keep the taps open. So that may also, cause needed more amount of water for that. And next is your, like, it also depends the amount of water which you are using. It also depends upon like the habits of the people. Okay, so if somebody is very, they are rich, or they are very in a, they are upper class community, so what will happen, they will use the water more. Okay, without being affected, so they will be using the water more. And they will, the middle class families or the middle class communities, they will consume the waters. Or if when the people are very, they are poor or they are slum dwellers, so they will obviously they will use the water very, appropriately. So these are also affecting the, like, the habits of the people. They are affecting the how much of water you are using. So that is also a factor. Next factor is your, like, the industrial and your commercial activities. So the wherever in big cities or towns, as I already said, where there are more number of industries, so more number of industries means more amount of water is being used. Okay, so that is this point. Then next is your quality of water supplies. So basically, if you are getting a very, a good quality of water, or if the taste is also good, see, though water is tasteless, but though it is tasteless, but if the quality is good, okay, so what will happen, people will consume more amount of water. Okay, and if in some places, suppose you are not getting a very good quality of water, then obviously the use of this water will automatically be less. So in this point, this is the thing. Okay, then next is your this pressure in the distribution system. So suppose you are staying in a third of story or a fourth story. So this pressure of the distribution pipes, it will be, if it is reaching the third or the fourth story, so the water consumption in the third or fourth story or fifth story, it will be, it will be more if the pressure in the distribution system or the distribution pipes is more. So like this, there are many points are there. Okay, there are many points. You can only you if when I have already shared this one, so you go through each of these points. So these are all easy basically points. So 5 points or 6 points I have already explained. Okay, so like this, there are some of the factors which all these things affect your this per capita demand. Okay. Okay, next we are coming to, okay, this PDF is finished. Let me, okay, next we are coming to some of the variations in water demand. How the demand of water, it is, varying according to, you can say, according to the months. Okay, according to the months, or in the different days of a month, or you can say how it is the water demand, it is varying according to the hours of the day. So all these things, there are many, like it is the what the demand of the water, it is, it is varying in the every season. Okay, it is varying in every seasons, and it is also varying in different, like, months. Then it is varying in different days of the month, you can say, and also it is varying in different hours of the day, and also it is even it is, it is varying in every minutes of the hour. So how it is actually varying? So see, this seasonal variations, if you say so, like these seasonal variations, it refer to, during summer seasons. So during summer seasons, obviously people will use more water than in your this winter seasons. Okay, so this is a seasonal variation. So it is according to the season, the water it is being used. So again, when it is a day variations, you can say, so like the water is varying, according to the daily variation. So how it is daily variation, it is like, like you are suppose you are staying in a holiday, suppose it is a Sunday, or it is on a holiday, so people are staying in their homes, so more amount of water it is being used. Okay, let me allow the other. Okay. So, what I was telling was that, okay, so during some holidays or during a Sunday, so people are staying in their homes. So what happens that people are using, on that particular day, the people are using the water in, like more frequently. Okay, so it is being used more. Then again, if you are going to say, like, what is a hourly variation? So hourly variation also, you if you look that, all the people they they are coming out to their office during like you can say like 8 a.m. to 10 a.m., or also you can say like 8 a.m. to 11 a.m. So this time like 8 a.m. to 10 a.m. also you can say. So during this hour, what is happening, the people, they are they're using the water more frequently, because they are cooking, they are cooking, or these people are who are going to their office, they are taking their baths. So for all these reasons, during a particular period of time in a day, suppose they are again coming back at 6 p.m. or 6 p.m. to 8 p.m. So basically this, there are some peak times in a particular day. So during those peak times, what is happening, the water is being more frequently used. Okay, so that is your hourly variations in a day. Then if you okay, so this is your hourly variation. So all the variations we have discussed. So like these are, these are the, it is in this diagram you can see. So it is showing that how the water consumption in a particular hour of a day, the water demand, it is varying. Okay, so like already I told, like from 8 a.m. to 11 a.m., the water is reaching its peak value. Then again it will decrease about around 1 p.m. when nobody is there in the home. So water use is will again, it will decrease. Then again during when the people will come back to their homes, and it will be again from 7 to 9 p.m. Suppose these are all approximate values actually. So like these are again the water demand, it is again it reaches its more value. So like this it is varying in a particular day. Okay, so that is your variations in water demand. So now when you are going to taking the variation, so why you need to know like in which period of in time the water demand is more, or during which seasonal time the water demand is more, or during which hourly time the water demand is more. This is all because you have to, while you are going to like design the water supply scheme. So during that period of time when you design a pipe or all these things, so you have to know all the variations that are occurring. Okay, so we have some different kinds of figures which are being adopted for all these things, all these variations. So what are all those different figures actually? So these are like there is one term which is your maximum daily demand. Okay, this is maximum daily demand, which is your the formula. Okay, this is a maximum daily demand. The formula is your 1.8 into average daily demand. Okay, this maximum daily demand, it is your, the formula is your 1.8 into average daily demand. And what is average daily demand? It is your small q. Okay, average daily demand is it is it is given by or denoted by small q. Okay, then it is your like maximum daily consumption. That means in a day, in a particular day, what is the maximum daily water consumption that is happening. So this is given by the formula 1.8 multiplied by small q, and where small q is your average daily demand, like what is the average amount of water it is being used daily. Okay, then comes your number 2 formula, it is your maximum hourly consumption. So maximum hourly consumption, again we have a different formula which is your 1.5. Okay, 1.5 into your average hourly consumption. Okay, so this is your 1.5 into average hourly consumption of the maximum day. So since it is an hourly consumption of the maximum day, so we are converting it to into a daily demand. So if you are converting it to a day, so you have to divide it by 24. Okay, so this is a 20, they are dividing it by 24. And what is maximum daily demand? Just now we have found out, it is 1.8 multiplied by q. Okay, so as a whole, if you multiply this 1.5 and 1.8, so you are getting it to be 2.7 q divided by 24. So which is also, you can write it as 2.7 in multiplied by annual average hourly demand. So basically all these things are not needed, but you have to remember this particular this formula. Okay, 2.7 into annual average hourly demand. So it will be needed while you will be doing this numerical. Okay, either you remember this 1.5 into average hourly consumption, or you remember this 2.7 multiplied by annual average hourly demand. Okay, so these two are the maximum daily consumption and maximum hourly consumption of formula. So next we come to like one term which is known as your coincidental draft. Okay, this is known as your coincidental draft. So coincidental draft is what, generally, it is the summation. Okay, you can say either it is the summation of your this maximum daily demand. Okay, in short, if we write it as MDD. Okay, maximum daily demand is in short is written as MDD, and maximum hourly demand, it is in short written as your maximum MHD. Okay, so if in short somebody writes MDD, so you should able to understand that it is they are talking about maximum daily demand. So this coincidental draft, okay, this coincidental draft, it is your this maximum daily demand, okay, plus your fire demand. Okay, we have learned about the fire demand, so I am writing it as FD. So this MDD plus FD, it is your coincidental draft. Either it is this one, or it is, it is your maximum hourly demand. Okay, either it is maximum daily demand plus your fire demand, or it is maximum hourly demand. So whichever you will calculate these two, so whichever value you are getting more. Okay, so in a numerical, if it is there telling you to find out the coincidental draft, so you have to first find out the maximum daily demand. Okay, so and also you have to find out the fire demand by using any of the formulas that we have learned in our last class, and then you have to again find out the maximum hourly demand. So by these two values, whichever value you are getting more, so that will be your coincidental draft. Okay, so this is your about your coincidental draft. So next we come to solve one problem. Okay, so that will be more clear to you while solving the problem. All the formulas will be clear to you. So here in this question, you see it is given, it is written as a water supply scheme has to be designed for a city having a population of 1 lakh. Okay, so estimate the important kinds of drafts which may be required to be recorded for an average water consumption of 250 LPCD. LPCD was what? Liters per capita demand. Okay, so also record the okay, this one is not needed. Also record the required capacities for this one is not needed. Up to here you have to find out. Okay, up to here it is required to find out. So they have given a city, you have to design a water supply scheme for a city which is having a population of 1 lakh, and you have to find out the different kinds of drafts. Okay, drafts you have to find out, and they are giving the average water consumption of water, that is your 250 LPCD. So now they are, since they are telling to find out the different kinds of the important kinds of drafts, that means you have to find out the maximum daily draft. Then this draft or demand is the same thing. Okay, don't get confused about draft and demand. Demand and draft, same thing. So this maximum day, you have to find out the maximum daily demand or maximum daily draft, or then again you have to find out the maximum hourly draft. Then there is your fire demand. Yes, so all these things you have to like find out. But you know that the maximum daily demand formula was what? The maximum daily demand, your formula was 1.8 into Q. Okay, just now we have learned about that one. So it is your 1.8 into Q. So now you have to know what is this. You have to find out this Q because Q is not given. Okay, so Q is what? This is the average daily demand. or average daily draft. Okay, so average daily draft, how you will be going to find out, since the population is given to you. Okay, and the water consumption, the average water consumption is also provided to you. So if you both multiply this population and the average water consumption of the population, so you will be getting what is the average daily demand of the, of the city, or of that population. Okay, so you have to just multiply both the population and the average this water consumption, that is your 250 lpcv. Okay, so after multiplying, they are getting it to be 225 million liters per day. So million liters per day, again in short you can write it down as mld. Okay, they are writing it as mld. So this mld is your million liters per day. So you have got your average daily draft, that is your small q. Okay, small q you have now found out. So now after finding small q, then it is now easy for you, because you know the formulas of MDD or MHD, all these formulas now you know. Yes, so now easily in next step you easily find out the maximum daily demand. Maximum daily demand, just now the formula I have written it as 1.8 into Q. So you just multiply these two and you will get it to be 45 mld. Okay, then next again you find out the maximum hourly demand. So what is the maximum hourly demand? It was your 2.7 into Q. Yes, 2.7 into Q. So just you multiply and you will get the this answer 67.5 mld. So these two drafts you have got. Now you since you know, you have to find out the coincidental draft. So there are three kinds of draft, right? Maximum daily demand or maximum daily draft, then your maximum hourly draft or maximum hourly demand, then comes your coincidental demand. Then for your coincidental demand or coincidental draft, you know that it is the formula is your MDD plus your fire demand. Yes, but now in this question you don't have any value for your fire demand. So now you have to find out what is the fire demand. Okay, so here you need to find out the fire demand. So how will you find out the fire demand? Here you will be using one formula of fire demand. Among the all the formulas, you are using this formula. Okay, now I will show you. Since the population here, it is given as 1 lakh. Okay, okay, so here you see in from this equation of 3 National Board of Fire Underwriters formula. So here they have mentioned, okay, about the population. They have mentioned here about the population that if the population it is less than or equal to 2 lakhs, okay, less than or equal to 2 lakhs, then you will be using this formula. Okay, so in our question it what it is given, it is given the population as your 1 lakh. So it is fulfilling this criteria. Okay, it is fulfilling this criteria of this National Board of Fire for a congested high value city. So you can now use this formula. Okay, for now that reason, now we are using the fire flow of or the fire demand rate of fire demand. We are using this 4637 root over p. We are using this formula. Okay, now what you need to do, now you will just put the values. Okay, now one more thing, that day I told you that since it is your the population in this formula, the p it is in thousands. Okay, p is in thousands, it is written there. So how will you find out this p? So whatever population you are it is given to you. Okay, whatever population is given to you, you will just divide it by 1000. Okay, so here basically it is given, your population is given to be 1 lakh. Okay, the population is given to be 1 lakh. So this one population, it is in thousands. According to the formula given by National Board of Writers, the P is in thousands. So you have to divide the population, whatever population is given to you, you have to just divide it by 1000. Okay, then what it will be? The answer, the P will be 100. Okay, you are getting the P to be 100. So any kind of population, whether if it is like 2 lakhs or 3 lakhs, whatever population they are giving to you, you have to, but you need to, convert this population into you have to divide it by thousands, since the this P, it is in thousands. Okay, so you have to just divide it by 1000, and you are getting this P now here as your 100. So now you just easily solve this equation, and you will be getting the fire demand as your 61 mld, that is your million liters per day. So now, after getting the coincidental draft, so now what you need to do, you have to find out the coincident draft. Okay, coincident draft, now we know that the formula is your maximum daily demand plus fire demand, and another one is your maximum hourly demand, which we have already been find out. Okay, we have already found out the maximum hourly demand. Now if you add this maximum daily demand and fire demand, you are getting maximum daily demand, you have got it to be 45, and then fire demand you have got just now as your this 61. Okay, fire demand you got it 61, so you just add it and you got it to be 106 mld, and the maximum hourly demand, which you have already been you have found out, you got it as 67.5. Okay, so among your between your 106 mld and 67.5 mld, which one is greater? 106 mld is greater. Okay, so you will be using 106 mld as your coincidental draft. Okay, so this is your about this
Ma'am,
numerical. Okay, yes.
About P, can you elaborate more about P logically? Because if we divide with the thousand, so how can that be an accurate calculation?
I didn't get you. What accurate calculation?
P. We
Yeah,
have to divide
yeah, you have to divide.
divide maybe divide by with the 1000
Hmm.
to any numbers.
Yeah, it can be any
So
numbers.
why it is required to divide that, or whether it will be accurate or not in the result?
I actually didn't get you. What accuracy you are talking about? Please ask some justified
Suppose
questions.
if we divide, suppose if we divide
Hmm.
1 lakh population by the 1000,
Hmm.
so how can be that calculation, the result will be accurate, since we have,
Why
deduct
you
the
need
population.
why you need the accuracy? Here they are not talking about
Bec-
any accuracy about this result. Whatever value you get, you have to put it. There is no any nothing about accuracy.
so what is the logic behind putting that,
What is the
divide with the
logic?
thousand?
What is the logic? In the
Yeah.
formula itself, they have mentioned that the population should be in thousands. Okay, the population should be in thousands. They have already in the last class we have already discussed that the formula, the P, the population is in thousands. So whatever population it is being given to you, you have to divide it by P. Sorry, you have to divide it by 1000. Since it is already mentioned that the population is in thousands, so you have to divide it the population by 1000. And there is no accuracy. Whatever population is given to you, you just divide it. It might come in decimal also, it might come in whatever. You just divide it, and you whatever value you get, so just put that value in P. You cannot use the whole population. Okay, you cannot use the 1 lakh, or you cannot use the whole of 2 lakhs, because since it is already mentioned in the formula. If it is not mentioned in the formula, if though it is already mentioned, but if it was not mentioned, then it is okay, then you can use 1 lakh. But here you have to, for every rate of fire demand, the population, it is in thousands. They have already, according to that board of writers, they have already mentioned that it is in thousands. So you have to divide it by 1000. Okay. Okay, then
Okay.
up to here. Okay, for today up to here only. So I will share this one PDF with you. You just one more time you go through this numerical and you just solve it. Okay, by using some different values also you can solve it by your own. Just solve it, because otherwise if you just see and in the class and you don't practice in your home, then you will forget it. And try to remember these formulas. Okay, the maximum daily demand, maximum hourly demand, all these formulas, rate of fire demand, just put it in your head. Okay, you have to memorize these formulas, because this will be again for every numerical in treatment also like this, so this will be used. So you have to be thoroughly cleared about these formulas. Okay. Okay, then let me take your attendance. Okay, so I will be okay. Attendance, I will be sharing a Google form with you. So CR will share the link with you. Okay, just in 10 minutes you have to fill it up. Otherwise, later I will just close the link. Okay, thank you everyone. You may leave the meeting now.